us all feel the presence of our Lord. Heavenly Father, we praise and thank you for this opportunity to share to your people the skills and knowledge of the event. May you bless each and every listeners and viewers that they may apply what they have learned in this Tech Talk session. May you be glorified in everything that we do. We lift up everything to you. This is our prayer. In Jesus' name. Amen.
Hey everyone! Welcome to our first episode of hashtag PSSE Tech Talk.
I'm Sean.
And I'm Trophy.
And we are your hosts for today.
So, Sean, I want to ask you something. How have you been?
I'm fine. A little busy with my projects right now, but I'm a little hectic. So, how about you?
Um, just like you, Sean, I'm actually doing great. Although there are some things that it's beyond my control, especially the deadlines of online classes. But nevertheless, I'm still coping up, with this new type of um, education that we have right now. So I want to ask our viewers, come on guys, how are you? How are you doing in this beautiful Sunday afternoon? So if you can comment down your thoughts, guys. How are you doing, our viewers? I hope you're doing okay in your houses, in your homes. Okay. Sabi ni Vince de la Cruz, pa-shout out daw.
So,
So, yeah.
shout out Vince de la Cruz.
Sabi ni Pia Bonilar, she's excited now. So yes, we are also excited for this event. So I'm glad to see that everyone is excited for this event. So Shan, I want to ask you something. Are you familiar about with Bitcoin?
Why, yes. Apparently, people who invested in Bitcoin a few years ago struck a gold mine right now. They are now instant millionaires. And I would like to ride that boat also. So, I'm very interested.
Ooh, that's really amazing. So I'm really curious and I really wanted to learn more about this topic. That is why I'm so excited for today's Tech Talk session.
Me too. So, without further ado, let me introduce to you our guest speaker for today's event. An alumni of SE Batch 2018, Mr. Rave Arevalo.
Let's give him a round of virtual applause. Hi, sir.
Testing. Hi, thank you, Sophie and Sean, for having me here today and for organizing all of this. You guys are just simply awesome. So, hi everyone, and welcome to PSSE Tech Talks. My name is Rave, and today we will be talking about the gears that power blockchain technology and demystify the processes behind what is now known as cryptocurrencies. So shout out to friends and guests who are tuning in over Facebook and StreamYard. Please sit comfortably, and I hope you enjoy today's talk. So thank you, Philippine Society of Software Engineers, for inviting me. And this is my first talk to be held in this format. I'm kind of nervous, but I'm very, very excited to share this topic with everyone here today. So, a little bit about me. I'm a software engineering graduate at Central Philippine University. So, shout out there to Sir Ku. I specialize in JavaScript development, and here are the technologies I currently work with. So, I hope you're seeing familiar faces here. We have Node, React, Go, and Docker. So after I graduated in 2018, I pursued a field of specialization, and that's on blockchain development. Most of my projects now reside on the Ethereum blockchain. Since I'm a big fan of emojis and icons, you'll be seeing them throughout the presentation to make things a little bit more interesting. Okay, I currently work with StackTrack and Kingsland University, so I'd like to thank Kingsland for my slides today. And to the software developers who are tuning in right now, explore your opportunities with us. Visit stacktrack.com or kingslanduniversity.com. We are looking for software developers and teaching assistants. So, without further ado, let's start. Let's begin with a little bit of history. Who, what, when, and where did blockchain come from? So pre 2008, this is when life is kind of normal. You know, we use cash for our transactions. Mobile banking is starting to gain traction. Then, around mid 2008, a certain Satoshi Nakamoto, the creator of Bitcoin, proposed a paper called Bitcoin, a peer to peer electronic cash system. And this was posted to a mailing list discussion on cryptography. Here's a snippet of Satoshi's original message. He goes in to summarize the main properties of his implementation, an explanation of the processes involved, and he attaches a paper right here detailing his solution for a trustless payment system. The identity of Satoshi Nakamoto still remains a mystery to this day. Nobody knows who he is, who she is, or who they are. So, Bitcoin began working in its full capacity shortly after 2009. So, mark your calendars because 2008 is the moment in time where a significant event in history happened. So, if you happen to have a time machine lying somewhere in your basement, travel to 2008 and get as much cryptocurrency as you can get your hands on. Because as of Friday, one Bitcoin is equal to 800,000 pesos. That's almost like, a million. So by 2011, as Bitcoin was becoming more and more popular, the idea of decentralized and trustless currencies caught on. So at this point, the first alternative cryptocurrencies appeared right over here. So we refer to them as Litecoin and Namecoin. And since Bitcoin's code is open source, meaning, the code is free to the public and everyone can modify it, people around the world were trying to improve on this underlying technology. So some offer greater speeds, better anonymity, or some other advantage. As a result, there are more than 1,000 different cryptocurrencies, and more are being created nowadays. Those cryptocurrencies are what we usually refer to as altcoins. So, yeah, they are altcoins. So you may ask, what's the difference between Bitcoin, cryptocurrency, and blockchain? So Bitcoin is the name of the digital currency that utilizes cryptocurrency. It's like, Philippine peso, but digital. And everybody here is called cryptocurrency, which is the technology that drives Bitcoin and others. And cryptocurrencies in turn are powered by a database-like technology called blockchain, which we'll dive into the technical specifications later. Now, when you hear about blockchain, it refers to the digital ledger technology, like the database like technology. When you hear cryptocurrency, it refers to all currencies here, as well as the underlying technology. When you hear Bitcoin, or later on Ethereum, it refers to a specific cryptocurrency. This brings us to 2013, where the price of Bitcoin reached 50,000 pesos, but quickly plummeted. What this means is that for a single Bitcoin you owned around December 2013, it costs 50,000 pesos. Then, in just a span of just 14 days, a single Bitcoin costs 23,000. That's like losing around 50% of the value within just 14 days. So imagine how heartbreaking this was during that time. So perhaps unsurprisingly, we're now on 2014 and ongoing. For a currency designed with anonymity and lack of control in mind, Bitcoin has proven to be an attractive and lucrative target for criminals. And in January 2014, the world's largest exchange, named MTGOX, went offline. And the owners of 850,000 Bitcoins never saw them again. Investigators are still trying to get to the bottom of exactly what happened here, but whatever the story, someone illegally got their hands on Bitcoins, which at the time was valued at $450 million. That's $1 million. And at today's prices, those missing coins are worth 13.6 billion. So this is just one of those significant instances during Bitcoin's history, and cryptocurrency is still being stolen from people at an increasing rate. So in case you see something like this in the future, an advertisement giving away cryptocurrencies this big, please, it's too good to be true. It's a scam, so please don't fall for it. 2 years after, around 2016 and 2017, Ethereum was born. And thanks to this guy, Vitalik, we are now able to run software on the blockchain itself. And the software that runs on the blockchain is called a decentralized application. And these are just some of the famous decentralized application that we have. Now, fast forward to today, 2020. Bitcoin is being adopted by major companies and institutions all over the world, and people are starting to appreciate the advantages of the platform, from banking supply to from banking to supply chain transparency. Okay. So moving on, when we say Bitcoin or cryptocurrencies in general, what do we know? So we know that the creator is unknown. We don't know if he's a he, a she, or an it, or a they. They could be your classmate or neighbor. No central authority regulates the rules of the currency. No government or individual can control what happens to it. And the asset has no physical tangibility. Its origins are purely digital. So if ever someone, gives you a Bitcoin in a form of a bit like metal coin, I kind of doubt that that's the actual Bitcoin right there. So public misconceptions, you're always anonymous. Nope, you are not. While some blockchains offer better anonymity than others, you can still be tracked if you're not careful enough. So it's certainly not a pyramid scheme. So be careful with those who offer cryptocurrency investments that promise 100% return in just 14 days or so. And a blockchain is not just limited to finance, just like owning a stock. It has other use cases as well, like healthcare and supply chain. To get there, instead of just explaining straight away what it means to have a Bitcoin, we need to create this feeling that everything is motivated. When we appreciate the architecture, sorry, we appreciate the platform as a whole. What we are going to do is walk through step by step on how you might have invented Bitcoin yourself. We will start with you keeping track of payments with your friends using a common ledger. Then, as you stand to expand and friends of friends of friends join, trust is getting more difficult. And you circumvent this need of trust using cryptography. What you end up is cryptocurrency. You may ask, ledger, as in an accounting ledger? Yep, Bitcoin is similar to an accounting ledger, which holds economic transactions in terms of, monetary units. So we have the following crucial elements here: the account information, the dates, the details, the debit and credit amount, and finally the balances. So it's worth noting that blockchain ledgers can become really big as time goes on. The Bitcoin ledger as of 2020 is 310 gigs in size, and that's still growing. Imagine downloading 310 gigs using the average Philippine internet. So let's just let it sink for a moment. So if you have a physical ledger, how does a Bitcoin ledger look like? So let's check out a real example of a blockchain ledger and identify the parts that's similar to the traditional ledger. So if you want to follow along, go to edu.kingston.io/Bitcoin-ledger. First up, we have the account number, which is defined by this representation. And the transactions, we have them here. Then we have the dates, just right. Transaction dates over here. Those in red would be the debit amounts, and those in green would be the credit amounts. And finally, we have the balance of this account just right here. Alrighty, moving on. The key to grasping blockchains is understanding cryptography, particularly cryptographic hashes. So while a blockchain has a lot of moving parts, you may hear decentralization, you may hear anonymity, or distributed ledgers. The foundation of this technology is in cryptography itself. Now, what is a cryptographic hash function? So according to Wikipedia, a cryptographic hash function is a mathematical algorithm that maps data of arbitrary size to a bit array of fixed size called the hash. In simple terms, it takes data and essentially translates it using the SHA-256 hashing algorithm into a string of letters and numbers with fixed size. In this case, it's a 64 character length of output. So the word deterministic here, meaning you get the same output for the same input every time you feed this into the hash function. So if you put Kingston again, it's not going to be entirely different. It's always the same. And irreversible, meaning it's a one-way function. That is a function which is like practically infeasible to invert. So think about a blender. You add ice, milk, mango, sugar, and several secret ingredients. Again, deterministic in nature. When I mention these ingredients, you already know what to expect. It's the chaos inside the blender. So you expect a mango shake. So let's try to blend them in. And now we get our mango shake. So, however, it's practically infeasible to invert a hash function, and it's also infeasible to revert the ingredients back from your mango shake here to how they were before. So that's a general gist of how cryptographic hash functions work. So we have some samples here of our hash functions. So no matter how long or short your input is, you'll always arrive at the same hash length, which is a 64 character length of output. Now, moving on, imagine this scenario. You and your friends exchange money frequently, like splitting transport costs, food bills. It's pretty inconvenient to exchange cash all the time. This is why you keep a common ledger where you record payments that you are going to make in the future. So, this ledger is where you write down what you need to pay and how much you need to get paid to eventually settle. The problem with this public ledger is that everyone can write down that someone owes him money, even if they really don't. So one morning I wake up and realize that I owe 200 pesos and I don't know why. How do we eradicate this problem? One solution is to use something called digital signatures. They are like handwritten signatures, but you should be able to add something like this next to the transaction. So instead of attaching this signature into our ledger, we'll attach something like this representation just over here. All right. So no one should be able to forge this signature. Everyone who participates in your BFF ledger now is given a key pair. So one is a private key that must be kept secret by the participant, and a public key that can be announced to the public to verify the signatures. So you may ask now, they are just a string of letters and numbers. How do we prevent forgeries? Can't we just copy this digital signature right here and say that we authorize the transactions? Well, you can't. In the real world, the signature is always the same, like this. But in the digital world, the signature is always completely different. So you can't have two messages signed with the same signature, and altering the message of the signature of, and altering the message here alters how the signature should look like completely. So we only change this word and everything here looks completely different. So in other words, the digital signature is a function of the message and the private key. Now, for example, you have our message here as bus fare from Irene costs 200 pesos, and someone signs this private key. Say Irene signs this to prove that she actually owes 200 PHP. So that will give us the digital signature, which looks like this. Now, the public key can be used by everyone to prove that the message is indeed signed by the person who actually said it. So again, our message is like this: signature from Irene, and finally Irene's public key. Now everyone can verify that this message is actually signed by this public key. Okay. Now, should a forged signature float somewhere, so say someone altered the message to point to Noel and increased the price or the value here, this is a forged signature. Notice that Noel just copied the signature of Irene here. And everyone can be able to verify that the signature has been forged, as Irene never actually said this in the first place. Okay. This is like a nice infographic as to how everything works here. So we have the public and private key pair and the message. Then everything here goes to a signing algorithm. And these are the elements that get released to the public. So everyone knows the public key, the signature, and the message. Then anyone who is interested can be able to verify using the public key plus the signature and message to verify that indeed this message is signed by the person who is holding this private key. That kind of seems complicated, so I prepared a demo here just to see the real world example of how everything fits. So let's try to open this up. Okay, there we go. So first, we are going to retrieve our private and public key pair. So they're found somewhere here. Just going to generate them. So the private key and public key looks like this. Now let's say I'm going to use this private key. Now I'm going to use my etherwallet.com to like access this private key for here. And let's try to sign a message. Say I'm going to sign that I am here on November 22, 2020. Like that. Sign it. And this is how the signature would look like. Now, if everyone wants to verify the message, we're just going to put it on a verification like algorithm. The public key is this representation right here. This is the message, and this would be the signature of this message. So if everyone verifies, they will see that indeed the person holding this public key signed the message saying, I am here on November 22, 2020. Now, what if they altered this to say, I am here on November 22, 1990. Oh, sorry. November 22, 1999. Okay. The message is altered, but the signature is still the same. Verify, then that gives us an indication that the signer did not actually sign that message. So that's for how the transaction signing and verification would work. Moving on, you might come across a question. Where is this digital ledger stored? The answer, everywhere. What do you mean everywhere? Everywhere, as in right now, there are about 8,000 machines across the world hosting the Bitcoin ledger alone. That's 310 gigabytes worth of data scattered across the globe. This machine could be a Raspberry Pi, a laptop, or a server on Windows, on Linux, everywhere. So blockchain networks, decentralized by nature. Yeah, just like, if you're familiar with torrenting files, that's how blockchain networks exchange information. So there is no single web server that tells anyone what the correct data is. Instead, what happens is there's like many different nodes here, and they tell each other what the correct data is. Okay. What's amazing about this is that like a change in one network here in USA can propagate all over the world in just 12 seconds. Imagine the scale of that. Now, how does a typical blockchain data look like? So there are three significant parts. Before we dive in, it's important to note that data-wise, there are three significant parts that are stored on the blockchain. These structures might have significant protocol changes, or there are additional significant parts on different blockchains. But for now, let's just stick to these three to simplify things a little bit. So first structure is a transaction. You have some notable elements here, such as the sender of the transaction, the recipient, how much is the exchange of value, a service fee of some sort, and a timestamp along with other data. So in the real world, this would not be Bob and Jane here. This would be that string representation of the public key. Okay. Now, all of the data that would be here is going to be hashed together and will be put into what is formally known as the transaction hash. In a way, the transaction hash serves as like an integrity check, for the transaction data found here. So if one of them is received incorrectly, the transaction hash won't be the same. Now, each transaction has a unique ID, and that is best represented by the transaction hash, which is what you'll commonly see just right here. Okay, moving on. Remember the private public key pair earlier? They will be used here. In this case, our message would be the transaction hash. And the private key of Bob will be used to generate this signature. And it will be attached into this transaction structure as signature. Okay, now we have a transaction structure that's unforgeable. And when an imposter goes in and tries to sabotage your transaction, say an imposter changed this value to 999, it will have like a cascade of failing verifications. So the transaction hash wouldn't match anymore and the signature would fail. Next, we have the block structure. So recall the processes that occur here. Everything here is hashed. We get the signature. And in one block, there are multiple transactions here, right? And what we'll do is that we will hash them again all together to form another integrity, which is now formally called the transaction data hash. It's the hash of all the transactions included in the block, right? Like here. Okay. Then all of the data here again will be hashed, and this will now form the integrity of the whole block and is formally known as the block hash right here. Now, this is our final block structure. And finally, if we assemble several blocks and chain them together, we'll have our chain structure. Each block has a reference that points to the block before it, like this. Okay? So it's it's like a linked list, but it's a linked list in reverse. So notice here that the first block doesn't have any previous transactions to point to, right? So this is formally called the Genesis block, and is sometimes used to check if you are on the correct blockchain network. So there we have it. This is our chain structure. And as you link these blocks together in a chain, what do you get? A blockchain. Now there we have it. That's a very high-level explanation of the structures that are within the blockchain. Now, how do we prove that your ledger is indeed legitimate? So there are around 8,000 nodes in the network. How do we prove that the other node is, his ledger is indeed legitimate? His records are indeed legitimate. So let's go back to our chain and pick this innocent block number 2 right here. So when a node receives a block data, it verifies if everything is correct, starting from the transactions here. So he verifies the node verifies the signatures, and if the transaction data hash matches, and finally the block hash. Okay. So if something does not match up according to the blockchain's rules, so for example, if the rule needs 3 zeros that precede the block hash, just right here. If everything in this block is valid, except for this block will still be rejected because it fails to follow the rules of the blockchain network. And oh, what is this? Another imposter who wants to sabotage our operations. So let's see what happens. What happens here? So it seems like he inserted a fake transaction that tells the network that Bob has sent him coins. Again, before the node accepts this block as part of the chain, they will verify the transactions first. And we'll immediately see that this transaction does not match correctly due to a forged signature. Usually, the validation terminates here and the block is rejected. But if the validation still continued, a different transaction data hash will occur. And when the block is hashed again for the block hash, a radically different block hash will be computed. And you know what happens to an imposter defending himself against 8,000 nodes? It's kind of sus, so let's vote him out. Okay, enough with that reference. Let's move on. Onto our final blockchain mechanism. We have mining. So mining also means this is where people earn money on the blockchain. So now that we know our block and chain structure, let's examine the processes involved when a new block is added to the chain. So in this case, we will mine for block number 4. When you send a transaction to the blockchain network, it does not get added to the chain immediately. What happens here is that it will go to the mempool first. And a mempool is like a cryptocurrency nodes mechanism for storing for storing information on transactions that are yet to be included in a block. So think about it as like a sort of waiting room for transactions that are not confirmed yet. Now here's our miner looking at the mempool to select potential transactions. But in reality, it's actually like this. So it's not a person who watches the mempool. It's everything is automated. And there's no soul behind the computer that actually always manually selects the transactions from the mempool. Okay, so let's call our human miner back to the stage so we won't break immersion. Suppose the miner has selected this subset of transactions to be included in block number 4. After validating the transactions, he now mines the block according to the rules of the blockchain network. So in our blockchain network here, we require that the block hash should have a difficulty of 3. So what does a difficulty of 3 mean? So difficulty here refers to the number of zeros that precede the block hash. Later on, we'll see why this is relevant. So this means that miners need to find a nonce, which when hashed together with the block data hash, just right here, will give 3 leading zeros. Okay, so this is like how the process is. How the whole process is involved here. So we're looking for the nonce. That will give us 3 zeros. Okay, so if we arrive at 5175, so 5175 plus the block data hash, we'll get 3 leading zeros. Okay, it replayed. So let's move on. This whole repetitive process here, just to come up with a hash that satisfies the rules of a blockchain, is called looking for the proof of work. So what this means is that your computer has actually put in actual computing resources to come up with the correct nonce. So this is where people get rewarded because they secure the blockchain network by validating the transactions within the block. So the better your machine and the greater your computing resources, the faster you'll mine a block. Our miner now does this over and over again until he finds the correct nonce. It gives him a block hash with 3 leading zeros. Now the correct solution is found. Our miner broadcasts this block data to the blockchain network. Like, hey, 8,000 nodes are all over the world. I found a new block. Now, other nodes in the network will verify if the new submitted block number 4, is indeed legitimate. And after some time, block number 4 will become a permanent part of the blockchain. Oh, your reward. Hello, miner. I almost forgot. Your reward has been credited to your account. The system automatically inserts your reward as part of the transactions. And it comes from an account called the Coinbase account. This is a special system account. It has no private key to sign the transactions, and it's usually reserved to credit the rewards to the miners. Now, in the real world, when someone successfully mines a block, the reward that he will receive is approximately 6.25 bitcoins. Yeah, seems okay, right? But let me put that into perspective. 6.25 bitcoins as of today is worth 5.6 million pesos. That's one large number right there. So it's like mining gold. But instead of you digging underground, you're digging using your computer in the infinite space of numbers and mathematical rules. This is why like everybody is going crazy just to mine blocks because the reward is really, really big. So the better your machine and computing resources, the greater your chances are of mining the next block. So what I mean by this is that there's not only one miner who calculates the next block. There are like a lot of miners who compete with each other just to generate the next block and get that block reward around like 5 million. And the one who solves it first most likely had powerful computing resources. At the end of the day, this miner here gets that juicy block reward, and the proof of work of other miners here will be rejected because he solved it first. And the whole process starts over again for the next block, for block number 5. Okay, so this seems like that's a lot to take in. So I have prepared a demo here that demonstrates the mining process. So let's just open that up. Now, when I click on mine here, this will start to calculate the proof of work. Now, what this is currently doing right now is that it hashes the nonce. Okay. It hashes the nonce plus the integrity of our like fake transaction here. Okay. So we come up with a proof of work that satisfies the difficulty of our blockchain network, which is like 3 leading zeros. So if we try to calculate this manually, let me just start to 56. Okay. So again, it was nonce plus integrity. And now we end up with 3 leading zeros. Okay. If we get like the incorrect nonce here, for example, we change this to like 2, 2, we come up with a really, really radically different output over here. And that's not like 3 leading zeros to begin with. Okay. Now, what we discussed earlier emphasized Bitcoin, but for any other cryptocurrency, the underlying principles are still the same. But they will have like different sets of rules, market prices, and block structures. Okay. Now let's put it all together and let's try to weave the whole process in one story. So once upon a time, Bob wants to send this is an Ethereum. Okay, so once upon a time, Bob wants to send Ethereums to Alice. So Bob prepares his transaction, wherein he says, gonna send Ethereums to Alice. It's from me. And I will send 143 of those coins. And he can attach other messages here too. Like in this case, he said thank you. Now, again, everything here will be hashed into what we originally discussed as the transaction hash. Then, Bob uses his private key to sign this transaction hash, and he attaches it to a transaction under the field name of signature. And he sends this transaction to the Ethereum network. Now, when he sends his transaction, again, it's not immediately added to the blocks. It has to go to the mempool first, which is like a list of pending transactions. This is his transaction here in green. Then a miner comes in and selects a subset of transactions within the mempool. So he comes up with this transaction data hash. And in a background, let's say he went through all the mining process. It's very long. And once he comes up with a solution, he sends this to the network. And in turn, everyone in the network would verify if indeed our miner here has solved the nonce correctly. And if everything is just looking good and in place, that gets added to block number 5. And when Bob's transaction is finalized in block number 5, Alice now gets to receive the coins from Bob. Oh, okay. I forgot something here. Okay, so let's try to fit everything in the real world, how the processes happen, what tools are used to interact with the blockchain network. So for this demo, we're going to use Ethereum as our blockchain network. We're going to use Etherscan to check if our transaction is indeed in the block and is finalized. And we'll use MetaMask. This is a Chrome extension to interact with the blockchain. Okay, let's just pull that demo up. Okay, so MetaMask is here. So if you're actually really interested to check this out, you go to metamask.io and you install the plugin. Okay, moving along. So here we have Bob and Alice here in the same account, just for demonstration purposes. So Bob has a representation of his private key, I mean public key, that looks like this. Okay, one moment. Okay, this is how his public key currently looks like. This is what is formally called an address. But for the purpose of this demonstration, let's simplify this to like a representation of a public key. Then Bob's private key looks like this. This is his private key, and he should keep it like private. He must not show this to the world, because if anyone gets a hold of this private key, they can be able to like impersonate Bob. Okay, now Bob wants to send say 2 ethers to Alice. This is Alice right here. Now Bob clicks on this send, looks for Alice's account, which is represented this way, and puts this amount. Oh, okay, sorry. Okay, I have to do that all over again. One moment. Okay, 2.5. Okay, now Bob clicks on next, and the transaction signing happens in the background and is taken care of by MetaMask. Now, if we click on confirm, we'll see that the transaction is still pending. We're going to use Etherscan here to check for our transaction. Now we see that it's still pending. In the background within the blockchain network, miners are looking at the mempool, and we'll try to include our transaction in the next few blocks or so. So let's wait for a few seconds for our transaction to be finalized. Okay, still pending. Okay, it's also worth noting that we're on the testnet, and the ethers here, the coins here, doesn't have any value at all. It's just for testing purposes. But 1 ether as of today is equal to 26,000 pesos. Okay. Now we have seen here that the transaction is now included on block 9118213. So if we check this block, we're not like just alone here. We have other transactions here too, along with our transaction. So all transactions here have been finalized. And when our transaction is included in a block, Alice now receives the coins from Bob. So I think that's it. So that concludes my talk. Thank you, Philippine Society of Software Engineers and audience all over the internet.
Yes,
Thank you, sir, for that very informative presentation.
So
All right.
yes, thank you very much, sir. To our viewers, now is your time. We are asking you if you have any questions about the session or about the topic that Sir Rave have discussed. You can comment down all of your questions, and Sir Rave will gladly answer them. So just keep your questions coming. So as we wait for your questions, guys, I want to ask Shan first. So Shan, what are your key takeaways from this session?
Well, I'm very fascinated by the fact that the cryptocurrency has this distributed public ledger or an accounting record book that does not have a central location since it's decentralized. And it's also nice to know that it is based on actual cryptography, not just the name.
Hmm.
So how about you, Joe?
Yeah. So actually, I'm kind of interested as well, as I have heard about this since I don't have any idea about it before. So I'm kind of that idea that struck me is that it uses a hashing algorithm. Correct me, sir, if I'm wrong. Hashing algorithm,
Mhm.
especially in hashing all the contents of each blocks. Am I right?
Yeah,
Uh,
you got that right.
yeah, so that's my key takeaways. I think it's amazing because of course we have learned that, diba? Um, uh, in our subject. So so guys, once again, we would like to ask our viewers, come on guys, if you have any questions about surveys, about cryptocurrencies and stuff, you can just comment down below. And we will entertain your questions. Do not be shy. This is your time. This is your time. If you have any questions, curious about blockchain, cryptocurrencies, and stuff. So,
So,
ladies, is there?
so actually, a person messaged me and want to ask her something. Since a cryptocurrency is mined with your computer, what are you, sir? Are you familiar, sir, with other mobile? How about mobile mining technologies? For example, the Pi network cryptocurrency, and is it
Hmm.
feasible?
Pi network cryptocurrency. I'm not really familiar with Pi network, Pi cryptocurrency, but it's feasible to mine on mobile. But for Bitcoin and other like major cryptocurrencies right now, it's really, really not feasible to mine on mobile. Your battery will just drain and you will not be able to mine anything at all because you need more like faster, more powerful machines. So if you really need to like pursue mining on mobile, hmm, imagine that you're up against Nvidia RTX 2080 and your mobile chip is like what MediaTek MediaTek. So the processing power is not that like not the same.
So I hope we answered your question. I, sir, would like to ask my personal question. Since some currencies are based on a gold standard, what is a cryptocurrency based on, and how does it have a value?
So right now it's important to note that everyone just appreciates Bitcoin just like how you appreciate um paper money, right? Paper money is just paper. It's nothing. There's nothing there. But it's the people who put a value in that money. It's the same as with cryptocurrency. People appreciate the value that it gives to the society, and people just kind of put in their like their value, associate their value to that currency. So people would say, okay, $1 is equal to 52 pesos. That's also the same as people saying, okay, one Bitcoin as of today would be equal to like, 800,000 pesos. So it's the exchanges that kind of regulate that. Okay, let me see if I could share something here. Um, okay, let me see. Um, Okay, so, hmm, can I have permission to share the screen? Okay, so if you look at here, this is like the evolution of how Ethereum evolved over time. So as of 2017, people just value this as like 491 pesos. Then as time evolved, there's like ups and downs here for the value until it kind of stabilized over time. So right now it's valued at 26,000.
Thank you for that answer, sir.
You're welcome.
Yeah, I want to ask another question, sir. Though this is not technical, but if someone is interested in involving in blockchain or in cryptocurrency, what can you advise to them, especially now in 2020?
So now in 2020, the blockchain technology is still, it's kind of in the middle of mature and evolving. And if they're kind of going to immerse themselves in the technology now, they will have like an edge for other developers who are, not kind of interested into this space. They will have like that edge in regards to like knowledge, if they want to pursue learning about this technology. And it's cryptocurrency is very, very diverse. So they could specialize in Ethereum, they could specialize in Bitcoin, and they just kind of know the ins and outs of those technologies that evolve over time.
So, sir, can you suggest, sir, what kind of where if I'm a person who wants to study about these things, what where can I pursue that study? I mean, I don't have any idea about it, but I'm interested. Can you suggest, if you can, because you can suggest a platform or something where I can study about those things or topics.
Oh, okay. So incidentally, kingslanduniversity.com. I mean, Kingsland University, my company, is like a teaching company where, where we teach blockchain to people. And it's not blockchain like high level blockchain. It's actually blockchain from the ground up. So you will be designing your blockchain blockchain starting from your own hashing. How do I put this? You're going to design your rules per se of your blockchain network. But if you're actually like interested to learn just the high level parts, and for you to be able to interact with the blockchain, say Ethereum smart contracts, there are a lot of nice resources over the web. And one thing I actually really like when I was still learning the ropes into this for this thing is cryptozombies.com. Let's see. Cryptozombies.io. Okay, so can I ask permission to share screen just to get get everyone on the same page? So yeah, cryptozombies.io. There's like courses here for you to learn interactively how to interact with like the Ethereum blockchain network. And as you grasp concepts like these, you'll be able to interact with other blockchain networks too, not just Ethereum, you know. Yeah, so they teach using zombies here to get everyone up to speed. It's really, really fascinating.
Wow, thank you, sir. So, guys, mga viewers, if you're interested, just search Kingsland University. Yeah,
Yeah,
and this, yeah,
kingslanduniversity.com.
yeah, and then you can also search this, the recommendation or the suggestion of Sir Ray. So, if there are more questions, if you have more questions, guys, viewers, just comment them before we conclude this event. This is your time, guys. This is your chance to ask questions. It's Sir Rave.
Yeah.
Don't be shy.
So I
Don't
think,
worry.
I think people are shy to comment. So they
Yeah.
another one messaged me and asked what factor since a cryptocurrency can be mined, what is stopping everyone from mining a cryptocurrency?
What is stopping everyone from mining a cryptocurrency? So, in the context of here in the Philippines, if we are to sync the the whole blockchain data, that's 310 gigs. So that's kind of not levels the playing field there, because not everyone has access to very, very fast internet. And if in case you have a fast internet, the problem now would be for you to have a um faster computing resources. So you need to invest in graphics card, you invest in ASICs. So those are like specialized processors just for mining. And okay, let's see here. Let's take a look at the hash rates right now on blockchain network. Okay, today's total hash rate is 133 million, was this terahashes per second? And if you're going to compare one graphics card, Q mining calculator, let me just pull that up. Okay. So if you have, say, what's this? Can we find for RTX 2070, for example? Okay, so in Iloilo, that's like 10 pesos per kilowatt hour. So your hash, okay, do we have like hash rates here? Okay, so your hash rate would be only around, say, okay, so you're only around, if you're going to mine alone, your hash rate would be 42.7 mega hashes per second. And you are against what? 130 million terahashes per second here. So that's really, really, really low. And you know, if you're lucky, this is like a lottery play. If you're lucky, you could be able to mine a Bitcoin, but the chances are, chances are really, really low. You're against people who have this much mining power per se.
Thank you. Nice.
Thank you, sir.
Sir. So we also have, sir, another question from Adeline Malyare. She asked, "Hello, sir. I just want to ask, how secure is blockchain?"
Hi, Adeline. So, along with like technologies right now, blockchain has its own how do I say this, technical holes, but it's very, very, it's like theoretically it will happen, but right now the chances of that happening is very, very slim. How secure are your funds? So let me just take this infographic right here. Bitcoin funds secured by laws of physics. Okay, so let's take this nice infographic over here. Okay, are we able to maximize this? Looks kind of low. Okay, I hope you're able to see this. So, if for example you have your own like Bitcoins, right, on your own account, that's just simply you being in possession of this private key. So, for example, here, this private key. Okay, let me just look for that. Okay, oops. So this private key here holds 2.5 Ethereums. So that's like 50,000 right now. And if people were to like hack this this account, they would count from 1 to 2 raised to 256. Okay, can I zoom this much more? Okay, so they will count from starting from 1 to 2 raised to 256, just to like brute force this private key that you have here. And even if you get a computer to count from 1 to 2 raised to 256, you will you'll kind of not finish counting from 2 raised to 256, because if you, for example, you're going to expend energy, right, just to count from 2 raised to 256, the sun will just but how do I put this? The sun will just explode into a supernova, and you won't be able to finish counting to 2 raised to 256. So your money is secured by the loss of the universe itself, because you won't be able to count from 2 to raised to 256 here. I guess that explanation is kind of confusing, but but I hope you get the gist why your funds now are secured.
Thank you, M. Thank you, M. Thank you, sir, for answering that question. M, I hope that your question has been answered. So, okay, so I think this is all. These are all the questions that we have for today's session. So, meron pa bang ano? Oh, we have another question by Nick's
Right. So
Dorgo.
thank you, Nix, for asking a question. So she said, "Hello, sir. How would someone go about securing their self-made cryptocurrency with blockchain technology?"
Okay, let me pull up those. How would someone go about securing their self-made cryptocurrency with blockchain technology? Okay, so in case you pursue creating your own cryptocurrency, the elements that I have discussed earlier, wherein you need to put, okay, let me share that presentation real quick. Okay, so the elements mentioned here, wherein you need digital signatures to prevent people from impersonating other people, would be one aspect that you would need to look into. Then you need to come up with your own. Okay, let me just search for that slide. You'll need to come up with your own. You need to come up with your own. How do I put this? Consensus algorithm, like this one, just to secure your implementation, wherein people like have this breathing space to like get the next transactions finalized and put them in a block. So in a way, it's kind of immutable, right? So say your transactions are finalized on block number 2, and for example, block number 1 here got kind of hacked in the middle. For example, the transaction data hash doesn't match, so your chain would kind of broke there, and that's natural. If your chain breaks, meaning something is not really correct per se. So that's the beauty of the blockchain network. Once everything here is finalized within the blocks, no one should be able to overwrite their own transactions. So again, you would have to look into using digital signatures to secure your transactions, and come up with your own consensus algorithm.
Right. So thank you, sir, and I hope we answered your question next. So guys, that will be the last question from our audience.
I would also like to add here. Let's see. I'm actually sharing my. Okay, let me ask permission to share my screen. So I would like to add that you could actually use blockchain, for example, the Ethereum network, to transfer funds to people all over the world, and it's very very cheap. So for example, if you're going to transfer something on the Philippines, if we're going to use like traditional money transfer agents, I'm not gonna mention everyone, but you get the gist. You get the gist of them. If we're going to transfer using them, we have this fee for every thousand that we send, right? So for example, we add 100 every time we for every for the money we send over anywhere in the world, and the fee is kind of high. But if we're going to utilize a blockchain, for example, Ethereum, to send funds, we'll see that the transaction fee is really, really low. And it doesn't matter if you send millions, the transaction fee would still be the same. So right now, the average transaction fee is 0.001 ETH, and that is equal to 27 pesos. Imagine how cheap this is. So I hope people would be interested enough to consider blockchain to send their funds all over the world, and see that sending transactions anywhere is going to be really really cheap.
Thank you, sir. Sir, there is pahabol question.
All right, let's do this.
She asked me, I want to ask if learning blockchain is hard and how hard it is when it comes, especially for the first timers, like the people who wants to learn. So how hard it is, sir? Thank you very much.
How hard it is. I think hard would be you're going to be overwhelmed with the technology because there's a lot of coins popping in right now. And what you would like to do first is to just understand those hashing algorithms that we talked about earlier, understand how they fit into the ecosystem. And once you get that gist of that, like for example those mempool that we discussed earlier, like the whole process itself, once you get the gist of that, you'll be able to understand how blockchain works, and the principle is the same on all blockchain networks. So if you ever want to start learning some nice overviews here, if you're really into it, so go to cryptozombies.io and you'll see some nice interactive demos for free.
Thank you, sir. So I hope na we have, sir, have answered your question. So, guys, our viewers, are there still people who wants to ask? Come on, before we finally conclude this session. Mga pahabol nga questions, guys. Do you have any pahabol? Going once? Going twice? Okay, so we're now finally closing the question and
All right.
answer. Sir, we are very thankful for your time and efforts, especially in speaking about blockchain and cryptocurrencies. And because of that, we would like to give you this certificate of appreciation to you, sir.
Yay! Thank you.
So
Thank
the
you.
certificate reads, Certificate of Appreciation is given to Mr. Rave Arevalo for sharing his invaluable time and expertise as a speaker in #PSSE Tech Talks, Introduction to Blockchain and Cryptocurrencies, given this 22nd day of November in the year of our Lord 2020. Signed, Ms. Chofik C. Rabanes, PSSE President, and Mr. Richard Michael Waiku, PSSE Advisor.
Yay. So thank you very much, sir. So guys, before we finally officially end this live, we would like to call for everyone's attention. The PSSE is in collaboration with the Engineering Student Council and at the same time with the CPUR and with the different orgs of the engineering body. We are calling for monetary donations. I will flash the in the screen the accounts that if you are willing to give and if you are able to give to the people that are affected with the typhoon Ulysses, you can give in through these accounts. But if you do, if you can also give in kind. Um, if you're in a clan, you can contact this person in Capiz, in Iloilo, or in Antique. You can contact these people if you want to give in kind. So the specifics are here. The material donations for kids, the diapers, powdered milk, clothes, and blankets. So there are different protocols that we should also follow in giving. Let us always help each other, guys. For more information, we are encouraging you to like our page, Philippine Society of Software Engineers, for more updates, or the page of Engineering Student Council, so that the donation, you can get an update about the donation drive. So, sir, thank you very much. Thank you, everyone who are watching this live. We really appreciate you guys for being here with us. Thank you once
So thank
again,
you,
everyone.
thank you, Chofi,
And
Sean, and
thank
Philippine
you.
Society of Software Engineers. You're amazing, and I'm looking forward to future tech talks. And to the viewers all over the world, thank you very much, and stay safe.
So, guys, see you again in our next episode of hashtag PSSE Tech Talks. Bye.
Bye.
Bye, guys.
Bye.